Okay, this is section 1.6 in college algebra, rational equations. I'm David Dipple from Lone Star College, Montgomery. Okay, when dealing with rational equations, you need to realize that rational means fraction. So the first step is to set the denominator equal to 0, or not equal to 0 rather, because you cannot have 0 in the bottom of a fraction. Then clear the fractions by multiplying by the common denominator, and then solve and check to make sure you don't get back what you started with. The number you said you cannot have. Okay, if you have x over x plus 3, 1 over x plus 3, and 2, you take the denominators, which have x's in them. X plus 3, they're the same, can't equal 0. When you move the 3 across, you get x cannot equal negative 3. Now multiply by the common denominator, which is x plus 3 and 2. So I put a 2 on the top and x plus 3 on the top. Same thing here, same thing here. Then we cancel x plus 3 in the first one and the second one, and 2. Then you clean it up and you get 2x, 2 on top, and x plus 3 on the right side. Then when you solve that, subtract the x and subtract the 2, and you get x is equal to 1, which is fine. We just said x cannot equal negative 3. So x equals 1 is our solution. Okay, suppose you have 4x over x minus 1, 4 over x plus 1, and 8 over x squared minus 1. Okay, you set the denominator, all the pieces, this x minus 1, that x plus 1. This is just both of them. You set those not equal to 0. And what you come up with is x is not 1 and x is not negative 1. Then I multiplied the first one by the x minus 1 and x plus 1, the second piece, and the right side. Now the right side I went ahead and factored, then you can see what will cancel. And then you'll have 4x squared plus 4x minus 4x plus 4 is equal to 8. If you'll combine all the terms, you will get 4x squared, the x's cancel, minus 4, you can factor that, those are perfect squares. 2x plus 2 and 2x minus 2. So when you solve that, you get x is positive 1 and x is negative 1, but that contradicts what we started up here, which means we throw those out, and there are no other solutions. So there are no solutions. Okay, suppose you have radicals. When you have radicals, you need to make sure the inside is positive, otherwise you get an imaginary answer. So the first step is to set the inside greater than or equal to 0. Then if you will separate them, it's easier to work. If it's possible to separate, square both sides, and then you can solve them. Okay, here we have x minus 2. Here we have 2x minus 8. So those two inside pieces, x minus 2 is bigger than 0. 2x minus 8 is bigger than 0. Solve this one, you bigger than 2. Solve that one, you get 4 divided by 2. There's going to be 8 divided by 2 is 4. Now this is the most restrictive one. Bigger than 4 throws out more things than bigger than 2. So you keep the one that's the most restrictive. Okay, now we square both sides. If you square this side, you get x minus 2. And if you square this side, you get 4 times 2x minus 8. Because the radicals just disappear, make sure you take the 2 and square it to get 4. Okay, that gives you x minus 2 equals 8x minus 16. Subtract x. Okay, add 16, you get 14 divided by 7, x is 2. Well, up here we said x is bigger than 4, so 2 is too small. Okay, the next one, x plus 1, set it bigger than 0. X plus 3, set it bigger than 0. So you get x is greater than negative 1 when you solve this one. Subtract 3, you get bigger than negative 3. Okay, since negative 3 is the smaller number, we take the bigger than negative 1. It's more restrictive. Square both sides. If you square x plus 1 minus 4, you square the first one, you put them together and double it, then you square the last one. That's the pattern for binomials. So you get x plus 1, because you square this. Put them together and double it, gives you 8 with the radical. Square 4, you get 16. And this radical disappears. Now we have to clean things up and square it again. Now when we clean things up, you should get x plus 1 is equal to 7/4 because the x's cancel. Okay, then we need to square both sides again. So you get x plus 1's radical squared, and the 7/4 gets squared. So you get x plus 1 is equal to 49/16. Subtract 1, which is 16/16, and you get x is 33/16. Now 33/16, is that greater than or equal to 1? A negative 1? Yes, it is. It's positive. So that's our answer, 33/16. Okay, equations in quadratic form can be used by substitution. Instead of having like 4th degrees and 6th degrees, we'll substitute whatever's in the middle. We'll call that u. Then the first variable will turn into u squared. We'll then factor because it'll be something we've recognized. It's a quadratic then. And then we substitute back. Just for example, x to the 4th plus minus 4x squared minus 5, we're going to call x squared u. And so it turns into our u is our x squared. So x to the 4th is going to be u squared. So you just do a substitution. This will be u squared minus 4u minus 5. And then you can factor. To get 5, you get 5 times 1. So it's u minus 5, u plus 1. Then you solve it. So u is equal to positive 5, u is equal to negative 1. Now, u is really x squared, so we substitute back. We had x's. We turned them into u's. It was nice to factor. Then once we have our u answer, we go back to our x squares. So you have x squared minus 5 equals 5 rather, and x squared equals negative 1. This one won't work. So you get plus or minus the square root of 5, or plus or minus I. And at this point, we're not dealing with imaginaries. So it's plus or minus the square root of 5. Okay, if we get something messy like this, again, you call this x minus 1 u, and x minus 1 here, which looks like it's squared right there. So the 1/5 power is our u. So x minus 1 to the 1/5 is u, and then the front term is going to be u squared. So now we have this is just u squared plus 3, that's u minus 8. And we can factor. Or in this case, it won't factor because 8 doesn't have any factors that add up to 3. So we use a quadratic. Negative 3 plus or minus 3 squared is 9. 4 times 1 times negative 8 over 2. Okay, that should be negative. Okay, if you take your calculator, that gives you 1.7 or negative 4.7. And then if we go back, x minus 1 to the 1/5 is 1.7. X minus 1 to the 1/5 is negative 4.7. Raise both to the 5th power. So you get 1.7 to the 5th power is 15.2. Excuse me, 16.2, and then add 1. And then 4.7 raised to the 5th power, add 1, and I believe you get 2294. And since we have an odd root, a 1/5 power, you get a positive and negative answer. That's fine. So that concludes section 6.